Okay, let me give you another example. So given this series, if I were to put a 7, if I were to put a 7 into the x here, that would then give us this. So will this series converge or will it diverge? So looking at this series, if I were to put, let's say, 45 into the x, 45 into the x, will this series converge or will it diverge? So we are going to use the ratio test to examine this series. Okay, so with the ratio test, we're always interested in this value here. So get the next term divided by the current term. So n plus 1, put it into the n here. So that will then give us this. And then n plus 1, put it into where the n exists. So that's this bit here. And then put it into this n here. That's this bit here. So n plus 1 would be this whole thing here. And then an would be this whole thing here. So with the ratio test, we are interested in this value here. So this value, well, an plus 1 will give us this, an will give us this. So now it's just a matter of tidying this thing up. Here you've got one fraction divided by another. That's the same as you getting that same fraction and then multiplying the reciprocal. So now it's just a matter of tidying this up. So imagine this as this, and then imagine this as this. And then so imagine as that. So looking at this, you've got n x to the power of n here. So this will cancel out with this, and you've got you've got 3 to the power of n. So 3 to the power of n. So these two will cancel each other out, and then that's pretty much it. So you're left with xn on top. So you're left with xn on top. And at the bottom, you're going to be left with n plus 1, 3, 3. So this whole thing here will then become this, and then group all the n's together. So you've got your n plus 1. So basically, switch it, rearrange this to this. So remember, when you have absolute AB, that's the same as absolute A times absolute B. So that's the same as us doing this. Okay, so from here, that would then take us to here, and then from here, examine what happens here. Remember, n moves from 1 all the way to infinity. N is always positive, meaning that this thing will always be positive. This thing will always be positive. We don't really need absolute here because it's always going to be positive. So this whole thing here will then become this. So this thing here will stay the same. And then now when you have one block multiplying another block, you can take the limit of one block and then take the limit of the other block, and then just multiply the two limits together. So here you've got one block multiplying another block. So you can take the lit of the first block and then take the limit of the second block, and whatever the two answers, you can just multiply them together. But the thing is, as n heads towards infinity, the denominator will just get, well, as n heads towards infinity, the limit of this will be 1. It will be 1. So 1 times anything, it will be, well, from here we can just concentrate on this. So concentrating on this only. So what we've got here at the moment is, well, to use the absolute, to use the ratio test, we need to know the value of this thing here. Well, the value of this thing here, we just worked out, equals this thing here. So now if the limit of this, if the limit of this thing here is less than 1, we know the original series will converge. If it's greater than 1, we know the original series will diverge. So if we want to examine this, so remember, well, for this series, if we use a ratio test, the value of this thing here equals this thing here. So if we want to understand when this thing will converge, concentrate on making this to be less than 1. So concentrate on making this to be less than 1. So concentrate on making this to be less than 1. So if we want to know when this will converge, concentrate on making this to be less than 1. So concentrating on this to be less than 1. So that's the same as, remember, if you have apps A over B, that's the same as apps A divided by apps B. So that's the same as us doing this. X apps over apps 3 being less than 1. And then absolute of this positive number 3 here will always be positive, so we don't really need apps here. Okay, so now times both sides by 3. So this thing here will be less than 1 when apps of x is less than 3. So basically, you can put any number less than 3 into here, into the x, then the whole series will converge. So hang on. So after all this, absolute of 3 less than, absolute of x less than 3. So what that means is you can put a 2 into here, and then this whole series will converge. You can put a 1.7 into here, and it will still work. You can put negative 2.9 into the x here, and then the whole series will converge. Okay, so as it turns out, if you put any number absolute of x less than 3 into here, then the whole series will converge. Okay.